I like this problem from the Facebook Hacker Cup round yesterday, so I thought I'd talk through how to do it because I like that it has three parts that sort of build on themselves. And they all sort of follow the same structure, it just gets more complicated. So I thought it was a pretty nice progression. So what's the problem here? So basically, we have this string, and we want to type it with as few hand changes as possible. So we have to type X with our left hand and O with our right hand, and F we can type with either hand. Right, so for example, X has to be with the left hand, and then F we can also type with the left hand, and then O has to be with the right hand, so that requires one swap, from the left to right hand. To type this one, this one, I guess we type the X with the left hand, all the way up to here, and then we have to swap to the right hand for the O's, and then to the left hand back, for the X. So that's two swaps, right? So that's why it says two. And, this one, I don't know, it's a bunch of swaps, it takes six. So that's like part one. And then in part two, what's different is they ask you to do this for like all substrings of the given string, right? So for the whole string, but also for like, this prefix that misses the last character, and this misses the, the last two characters, and this segment in the middle. So all possible substrings, you're supposed to add them all up. That's part two. And then part three is the same as part two. You're supposed to do all the substrings, except they introduce this final type of character, a dot, which means like repeat the whole string so far. So that means the string can be like exponentially long. So that requires some more solutions. Okay, so I'll talk about how to do part three in a bit. Let's start with part one. And so actually all three parts follow the same structure of the solution, which is you have something you're keeping track of, right? Some state, and then you just go through the characters one by one and add them to the state. And then so for part one, it's pretty straightforward. As befits part one, you just need to keep track of which hand you're using and what the answer is. Right? How many times you switched. So if you see an F, you never need to do anything, right? Whatever hand you have, you can type with it. We're saying -1 to start because it could be either hand. And then if we see an X, we have to use the left hand. And if we are using the right hand, we have to swap over. And similarly, if we see an O and we're using the left hand, we have to swap over. And then after you see an O, you always have to use the right hand. So that's it for part one, is you just, go through the letters, keep track of how many times you switched hands and which hand you're using, and then you can put out the answer. So part two was the same thing, except we wanted it to do to all substrings. Right, so instead of just, the whole given string, we're supposed to do all of the, like, n squared or n choose 2 substrings. Right, a substring is just, like, any arbitrary, segment of letters. So that, might feel a lot more complicated. We went from wanting to solve, like, the problem for one string to wanting to solve it for, like, 800,000 squared strings. It's like a trillion strings. That's a big jump from 1 to a trillion. But we can still do it one character at a time by keeping track of, just a larger state. And so the key idea here is that each substring ends somewhere, right? And so as we add each new character, we're going to keep track of all of the substrings that end at that character. Right, which is all of the suffixes of the string so far. Right, so if the string is like XOXO, then, after X, the suffix, right, there's just one suffix, which is X. So the suffixes means, like, everything at the end, right? So everything sort of going back from the last character. So for XO has two suffixes, which are the O, and then the OX, right? So you just keep going backwards. XOX, has three suffixes, and except, like, the whole string. Sorry. So XO, this is O, has 4 suffixes. And, like, these are all the substrings of the string, right? All of these different suffixes. So that's how we're going to keep track of the substrings, is by, like, where they end. And so we need to keep track of some additional state for that, right? We keep track of, like, the final answer. And then also the total cost of all of the suffixes so far. And then we also need to track some information about the suffixes, which are like how many are using the left hand, how many are using the right hand, and how many don't care which hand they're using. So like F's don't care, right? Because that only happens if your whole suffix is F's. Yeah, so again, we go through the string one character by one character, just updating the state. Right, right? So if you see an F, so you do get all the substrings that end with F, but none of them really change cost if you think about it. Like adding an F to the end of the string, you never need to change hands, right? You can just use whatever hand you're already typing with. And then to type F itself, that doesn't cost, you can use either hand. There's no hand switches, obviously, to type any single character. So the sort of total cost of the suffixes doesn't change. But anyway, you add all the suffixes to the total cost, and then you mark down, okay, I have one more substring that's all Fs, right? In this case, just one F. But that's the one at the end. And then if we get an X, that means we need to switch to the left hand. Yeah, so actually, really think about it like that. So if we need to switch to the left hand, well, we might actually need to switch hands for some of those suffixes, which is all the ones that were ending on the right hand, they now need to end on the left hand, right? Because they need to type an X at the end. So we need to pay to switch hands for each one of those, right? And so that's why we want the count of that. We add that to the total cost of all of the suffixes, and then we can add that all those suffixes are substrings, so we can add them to the cost of all the substrings, and then we can update the number of suffixes of each type, right? That's the remaining state that we needed. So now, after you see an X, that means all of the suffixes are using the left hand, right? Because all the suffixes end with F, or end with X now, right? Because suffixes end by a suffix, I mean that it ends at the end of the string. They all end with X. And so they all end on the left hand, right? And then none of them end on the right hand. So this is the new one, and these are, all of the previously existing suffixes. And then if we see an O, that means we need to switch to the right hand. It's basically identical to this. You just swap all the lefts with the rights. And I'll make the same change. There, that's really the clearer way to think about it, right? Is first you figure out what's going on with the suffixes, and then you say, okay, all the suffixes are substrings. So it's just the same. And so a question you might have is like, how did we decide on this state? It's like, this one makes sense because we need to output the final answer at the end. We better compute that. And I think this thing makes sense if you sort of buy into this way of breaking down the substrings, is that we're just going to add, the suffixes as we end in each character, right? Or like we're breaking up the substrings by where they end. And then this, I think, just arises naturally, right? If you just think about, just trying to keep track of these two things, well, how do you actually update this as a new character comes in? It turns out that you need to know how many suffixes you were typing with your left hand, to pay the cost of when a right hand comes in. You need to swap. Well, how much is that cost? You need to keep track of it. So that's sort of, you get this state sort of organically by trying to figure out what you need to compute this stuff. And so that's a good way of sort of coming up with the state, is just like, figure out what you actually want and then see what you need, what information you need to keep track of that. And this might be an iterative process, right? You might say, okay, well, to keep track of all the substrings, I need to keep track of the suffixes. Okay, well, to keep track of the suffixes, I need to keep track of the counts. And, luckily in this case, that's where it stopped, right? Okay, we can just keep track of the counts directly, in terms of the other counts. So, hopefully that process stops at some point. You say, okay, well, to keep track of this thing, I need this other thing. For that thing, I need something else. Hopefully eventually you get enough stuff together that you can keep track of everything. But anyway, structurally, this has very similar idea as the previous part. Right? We're just adding the characters one by one and updating the stuff we're keeping track of. It's just that we need to keep track of a slightly more complicated set of information. And so part 3 is the same idea. Again, we're going to add the characters one by one, and we just need to keep track of, some more information. And one of those pieces of information is the total cost of all the substrings, and that's what we print out at the end. Okay, so it is longer, more code. So what are we keeping track of? So we're keeping track of the total cost of everything, right? That's what we're going to print out at the end. Obviously, we need that. We keep track of all the suffixes, which, we definitely need because we need it in the last part, right? This part is like a strict addition to the last part, is that we added this dot character, which means duplicate the string. Right, double the string size. And we need some other stuff too. So we need to keep track of the length of the string. Hopefully that makes sense. And the reason, well, so actually I decided to change up what I was keeping track of in part 2. Right, in part 2 I was keeping track of like how many were left, right, and don't care. And now I'm keeping track of the length and how many F characters there are at the end, and also which hand we're typing with. And that sort of encodes the same information. Right? If you know which hand you ended on, and you know how many Fs you have at the end of the string, where you don't care which hand you use, that tells you, and you know how long the string is, you can compute the number of suffixes of each type, right? Because basically, you're going to have a couple don't care suffixes, which is like how many Fs you have at the end of the string. Right? If the string is like, you know, FFF. Okay, well, for this one, I don't care which hand I'm typing with. For this one, I don't care which hand I'm typing with. For this one, I don't care which hand I'm typing with. And then for this one, I need the right hand. And then for all of these, I need the right hand, right? Because they all end with O. You know, this guy ends with O, this guy ends with O, this guy ends with O. So, you know, from those pieces of information, you can compute the number of suffixes of each type, which is what I wanted for the previous part. And then the major change here, as we'll see, is we need to keep track of prefixes as well as suffixes to handle the dot character. I'll talk about that later. And so for prefixes, you know, we need to keep track of the prefix cost. We need to keep track of which hand we started typing with, how many Fs there were at the start, right? These are sort of symmetric to, you know, the suffix, right? How many Fs we have at the start, how many Fs we have at the end, which hand we started typing with, which hand we ended typing with. Prefix cost, it's like suffix cost. And then we also need to keep track of the cost of the like total string so far, which turns out to be necessary for prefixes, but not for suffixes. And then we need the length, which, you know, I guess in the previous part, the length was sort of obvious, which is how many characters you added, but because the dot isn't like a single character, it's like double the string, you need to keep track of the length explicitly. Yeah, so once you sort of figured out your state, then you just need to figure out, you know, how to update it in response to each of the characters. So there's 4 characters that could come in, so there's 4 cases. Right, so if we add an F, okay, well that doesn't change the cost of the string so far. The string gets 1 longer. The suffixes don't change their cost. The cost of all the substrings, we're just adding up the substrings, you know, that end in this new character, like just like in part 2. And then the prefixes, right, so the way the prefixes work in general is when you add some new character, right, we have, you know, a random string, right, we have all the prefixes, this guy, and this guy, and this guy, and this guy, and then when you add a new character, this whole thing is a new prefix. Whereas for a suffix, you know, it's just the one character. So anyway, because you're adding, but the other prefixes that you have so far don't change at all. Whereas in the suffix case, you know, that character gets added onto all of them. So anyway, the point is you have to add the string so far to the cost of the prefixes because the whole string is a new prefix. This doesn't change which hand you started on or which hand you ended on. Obviously, we added an F, so we have another F at the end. And we also might have it might still be the start, right? If we only have Fs so far, this could also be the number of Fs at the start. If we had an X or an O already somewhere, then, you know, we've already gotten all of our Fs at the start, and that's never going to change. Okay, so that's sort of all the stuff, you know, to keep track of, right? This whole state. If we add, you know, if we swap to the left hand, okay, so if we were typing with our right hand, then we have to pay 1 to type the entire string. Otherwise, you know, it's free. For suffixes, right, all of the suffixes that ended with the right hand, you know, if the last character we typed was an O, you know, other than some Fs, then we need to swap all those suffixes over to the left hand. So that's what this term is. But if the last character we typed was an X, we don't need to change hands at all. The length increases by 1, the total cost increases by the number of suffixes, the cost of the prefixes increases by the cost of the total string, right? This was true when we typed an F, it's going to be true when you type an X and an O. These are all sort of the same. If we haven't picked a hand to start with yet, then we might as well start with the left hand, so we get the X for free. Certainly, you know, we've certainly switched to the left hand, so that's, you know, this is like the current hand. And we certainly don't have any Fs at the end of our string because we have an X at the end of the string now. O is just the same as X. It's just like symmetric. Just replace all the lefts with rights. So I won't go over it. I think it's like literally identical code except for that, symmetry. And then dot is the hard one, where you double the string. So that's basically why we have to make the state more complicated, is to handle dot. And especially, you can see this total cost is getting a little complicated. So the idea is, we have the whole string and then another copy of the whole string. So like, what substrings do we get? Well, we have all the substrings from S from the left copy, and then again all the substrings from F from the right copy, and then we have the substrings across the middle. And so the middle is like any suffix of S combined with any prefix of S, right? Like non-empty suffix and prefix. And those will cross the middle. Right, so first we take care of the ones that are just completely in either in the left half and in the right half. And then this is one crossing the middle term. So this says, like, all of those suffixes compare with any prefix, and there's this many prefixes. So, each of those suffixes is going to be contained in, like, S-len substrings that cross the middle, so we need to pay for it that many times. And similarly, each of these prefixes compare with any of these suffixes. There's S-len suffixes, so we need to pay for each of these prefixes n times. And then, when we cross the middle, we might have to swap, to change hands, right? If we were ending on a left hand and we start on a right hand, then we need to pay for all of those changes. Right, so that's what we're sort of calculating here. Right, this is if we ended on a left hand and we start on a right hand, or if we ended on a right hand and started on a left hand, right? We need to pay this cost. And what is that cost? It's just the number of suffixes that ended on that hand times the number of prefixes that started on that hand. Right, and so the point is basically, if you pair with Fs, you don't need to swap hands, because Fs you can type with either hand. But once you get to like the first character that's not an F, or the last character that's not an F, you do actually have to pay that switching cost. So this is the number of suffixes that actually like use that hand. They use end hand. And this is the number of prefixes that use start hand. And so you have to pay, like every time, each of those pairs, you have to pay one to switch. So that's what this complicated formula is for. Right, so how do we update the suffixes? Okay, well, what is a suffix of S, concatenated with itself? Well, it's all these suffixes here. Those are still suffixes. And then it's this whole string plus all these suffixes from here. Okay, right, so those are the suffixes. So it's all of the existing suffixes, and then all of these suffixes. And then all of these suffixes also include the whole string itself. So that's, the cost of the whole string. And there's S-len suffixes. And then if we need to change hands when we go sort of across this dividing line, we need to pay for that too, which is just the number of these suffixes that actually care about the previous hand, right? And they're each only getting paired up with, like, in this equation, they were getting paired up with all the different prefixes, but in this equation, they're only getting paired up with the entire string. So it's, instead of multiplying, it's just like this one term. Prefixes are basically symmetric with suffixes. You can see it's basically the same, except this is like start F, and this is, prefix cost, obviously. The length just doubles. That's easy enough. Multiplies by 2. The cost of typing S, well, you have to type the first copy, and you have to type the second copy, and you might have to change hands in the middle. So we can check for that. Which hand you started with and ended with won't change. And then normally the number of Fs at the start and the number of Fs at the end won't change, right? Because you just get, the Fs in the start here and the Fs in the end here, which are the same as they used to be. But if the whole string is Fs, that's like a special case. And then it doubles. So you need to keep track of that. And then at the end, we just spent the total cost. Yeah, so I guess the hard part here is coming up with the right state. Right? Once you sort of have the right state, you can just, figure out how it should change. And again, it's sort of, wait, so how did I decide to, track these like 10 different things? Well, I didn't just sit down and do it. But I said, okay, well, I definitely need this. And then, I need this from part 2, and I need this and this from part 2. And I need this sort of from part 2 because, I mean, I guess a change from part 2 is I decided to track the like number of different types of suffixes and prefixes in a different way. I could have, tracked it the same way. That would have been fine too. I don't know. I thought this was simpler for this part. And then if you think about how the like concatenation works, you will realize that you also need prefixes, right? Because you need to account for these substrings in the middle, which are a suffix plus a prefix. So that means you need to keep track of information about prefixes. And that's basically, the rest of it is, and then for prefixes, we end up needing the entire string. So you can sort of organically build this up by like what you need to track to like compute the stuff that you want to compute, right? Like just think through like how does that actually change, when you double the whole string, and like what information would you need to have about the string to figure out what happens when you double it? And it turns out you need information about both the prefixes and the suffixes, basically. Yeah, I guess I'll also mention a cool thing about this like multi-part thing is it made debugging easier. So I had an issue where I wasn't handling dot correctly, like in this case, and I was able to debug it pretty well because I just expanded out the dot, to XFOF, and that should be like an equivalent problem, right? You should get the same answer if you have a dot here or if you have XFOF here, right? That's like the definition of dot. And so I was able to just run both of those, and then I could really see where the bug with dot was, right? Like I could print out all this stuff and see, okay, when I'm at like, the XF, the eight length string that I get after this dot, XFOF, like the dot was wrong, like what happened there? So that was a nice way to debug, especially since I knew I had a working solution for part 2. Right, because if you just expand out the dot, now you have a test case from part 2. So that was neat. So yeah, that's all I wanted to say about this problem, and I thought it was cool. Hopefully you did too.